Alright, some quick kind of directed help on 6.5 for those who need it. These are my particular problems and their solutions just to kind of get you over that hump if that's a bother to you. These are polar graphs, 6 sine 5 theta. You should recognize the type of curve that goes with that. That'd be a rose curve. And because it has an odd number of petals, or a number next to theta, that would have this would be a rose curve with a radius. Each petal would be 6 long, and there would be 5 petals. If that's an odd multiplier to theta, you get that many number of petals, 5. If it's an even number multiplied to theta, you actually get double that number of petals. So when they ask for domain, domain is the input possibilities. Input is theta, so it's all reals. So anytime you have a polar curve, your domain is going to be all reals. Any theta is fine. Now the thing is, you're going to, as you increase theta, you're going to keep retracing the same graph. For instance, a rose curve with an odd number of petals traces out in 0 to pi. So anything beyond that, you're going to just be retracing your steps. The range of any theta curve like this, or a rose curve, well, the radius, the biggest it's going to be is 6 right here. This multiplier out front, if you think of what sine can be anything from -1 to 1. So the largest radius, r, is going to be is 6 times 1 is 6. The smallest it'll be is -1. So you'll see right here, -6 to 6 are the radii values that go with that one. Let's keep cruising. So that's number 10. I'm showing you this just to kind of get you rolling. Here's number 11. Here we are looking at a limicon. And in this case, 6, this out front value is larger than 5. So what we're looking at is a dimpled limicon because it's not twice as big or greater, it's just bigger. So we're looking at a dimpled limicon. Domain, all reals, because you can put any theta you want in there. Domain, remember, is input values, theta is our input. The range of this particular graph is all the possible. Now this one's a little bit different. With a limicon, you want to look at the smallest the radius can be. If sine is -1, remember sine can take values from -1 to 1. If sine is -1, this becomes a -5. 5 times -1. That'd be the smallest the radius can be 1. So that'd be the small value 1. I guess I can type that in here. And then the largest your radius is going to be is when sine is +1. 6 plus 5, you're going to get 11. So those are the range of values. And this was written in our notes when we did this in class. Some of you missed it. If you look at your note packet, it tells you what the possible range and domain values are for roses and for limicon curves. And they're not something that you hand wrote. It's typed in for you. So you want to double check and look for that in your note packet. Going on to 12. Number 12 is, if it'll turn, come on page, turn on me. I don't know if this is number 12 or not. I think it is. I can't see it on my sheet, but is that right? Yeah, number 12. Same thing. We're dealing with the same kind of problem. 6 and 5. It seems like it should be different. Did I have 11? Yeah, there's 11. 6 plus sine of theta. What's the range? Is it me or is that the exact same question? Well, if that's the exact same question, just answer it the same way. So I don't know what the deal is on that one. Number 13. Here we are again. This time number 1, the one out front, is smaller. And when this number out front here is smaller, you're going to have a loop that takes place, and because the difference between these is 1, you're going to have a loop with the size of 1. There are two, when you do a loop limicon, you're going to have a loop that's 1 long, but the overall largest radius is 3 that can be. So here's what's the domain of the graph of all in this particular. Again, any x you want to put in there, I'm sorry, any theta you want to put in there, those are the input values, possible inputs. That's what domain is all real numbers. Range on this one is the largest it's going to be is if cosine's 1, so 1 plus 2 times 1, that'd be 3. The smallest it's going to be is when cosine's -1, so you're going to get 1 minus 2, which is -1. So what you're going to choose is that first option here, -1 to a largest. That's the difference of those two values because you're putting in cosine of -1. Remember, just think of what cosine can be at its largest and smallest, -1 and 1. How does that affect your radius in the end? So -1 would be the smallest. If cosine were 1, think of the theta that would relate to that. Cosine's 1 at 0 and 2 pi. So that would make us a radius of 3, and that's the largest it can be. 14. This is analyze the graph of the polar curve. R equals 5 theta if you put it in there. This is as theta goes along. Your radius is always going to be 5 times that particular theta value. Now determine the graph's symmetry. So you're trying to think, what kind of symmetry am I dealing with? Well, you're welcome to graph it and take a look at it. That's the idea, and you'll find symmetry about the y-axis just by putting this into your calculator and graphing it r equals 5 theta. Feel free to just live with the fact that you're going to graph this in a calculator. You need to know how to graph it in polar mode. That's the big deal with this particular function. So you want to go to mode, polar, go into your calculator, put r equals 5 theta, and take a look at it. Is the graph bounded or unbounded? That means bounded means does it have a ceiling and a floor, or does it just keep going? Is it like unbounded graph would be like a line. A bounded graph would be like a circle, something that's contained versus something that's uncontained. So the next one, 15, state any symmetry of the graph that possesses and find the maximum r value. Well, symmetry, why don't you just graph this? Put it into your calculator, whatever you want to use. You can use Desmos.com, just plug it in and then zoom out a little bit and tell me about the symmetry. You'll notice there's symmetry about the origin. Any other graph, symmetry about the y or x-axis, I'm sure you could recognize if you graphed it appropriately. Use technology to your advantage on these. And what's the maximum r value? Well, take a look at what it can be. If the biggest sign's ever going to be is 1, so the idea is that you could have, and then 1, this is sine squared, 1 squared is still 1. So the biggest it's going to be is 5 times 1, which is 5, plus 1 more is 6. The maximum r value is going to be 6. In this case, just think of the possible sine values. You can look at the graph for that, but you just got to know a little bit about your trig to take that on. Hope that helps.